Quantum mechanics as code. Let's look at the next big clue and see how this bleeds into the totally bizarre world of quantum mechanics. Because if physics is code, quantum mechanics might just be the optimization algorithm. A really fascinating 2017 paper suggests that any finite system running a simulation would definitely try to save processing power. They apply this principle called information-based complexity. To keep computational complexity low, the system computes using partial or incomplete information. It basically only does the heavy lifting when it absolutely has to.
And when we look at the famous wave-particle duality experiments, we see this exact procedure playing out in nature. When a particle goes through a double slit, the universe seemingly only renders a definite reality, a solid particle pattern, when the which-way data becomes available to an observer, or when it gets recorded on a flash drive. But if that information is irreversibly destroyed, the universe just saves resources and renders a blurry wave pattern of probabilities.
So, the crucial takeaway here is that quantum mechanics behaves suspiciously like a video game engine. Think of games like No Man's Sky. The engine only renders the trees, the animals, and the geography when a player actually looks at them. It saves massive amounts of memory. And according to these researchers, the collapse of the quantum wave function operates on that exact same logic, generating reality purely on demand to save computational overhead.
The thermodynamic energy limit.
But hold on, before we declare ourselves literally lines of code and call it a day, we really have to face the hard physical limits of thermodynamics. Simulating a universe isn't just about writing clever software. It requires hardware, and hardware demands energy. This is a massive roadblock for the simulation hypothesis. Can any computer, even some godlike alien supercomputer, actually afford the sheer energy required to simulate our entire universe?
To answer that, we have to look to a physical law called Landauer's principle. It states that computation is inherently physical. Erasing or processing a single bit of information requires a minimum physical energy expenditure. There's a strict mathematical limit where generating entropy costs actual physical energy. In physics, there is absolutely no such thing as a free calculation.